An acid donates protons, correct?
Yes.
Bases accept
Bases accept
protons.
Mm-hmm.
That's based off of Bronsted.
Yeah.
Now Lewis says that acids wait, okay, so if this guy's donating proton, he becomes negative. So he wait, how's it come for when it comes for the Lewis thing, when it comes to electrons?
Lewis, yeah, he's an acids are electron pair acceptors.
Yeah, acids accept electrons, right?
Yeah, and bases are electron pair donors because they have the extra electrons.
The electrons. And bases. Wait, acids accept the electrons, bases donate.
Mm-hmm.
So they kind of flop what they
Yeah.
do. That's what I have to remember. Okay. So, in this situation here, that's my acid, correct? The HPO4?
No.
Well, here, how about this? I'll balance it, because I think it's going to do this. Want to do this? PO4. I want this to just be H2.
No, because if this proton's positive, so if you have two H pluses, it would be H2 2 plus. Because your overall charge has to remain the same, and you're at a -1 right now because you have a -2 plus a +1 equals -1. So you'd have to have a +2. So it's more likely that this H will join and become H2PO4.
Oh, okay. Dang. I was thinking I kind of had these things down. Apparently not. H2PO4. Okay, so now based off of that, I can figure this out. Wait a second, this is a little bit different. Oh, this becomes H2O, correct?
Yeah, this one's a bit different.
This would be PO4, and this one will be 3 negative, correct?
Mm-hmm.
And then this goes to, come on, H sub 2, oh.
And just check the hint real quick.
HPO2 is a amphoteric, also known as amphiprotic, which means it can act as an acid or a base, okay, depending on its context.
Yeah.
And isn't water like that too? Water can be an acid or base. Okay, so in that situation, so I think probably from what I've seen, anytime you see an OH, you know water's gonna form.
Yeah, well, yeah, pretty much.
Okay, so he became more positive and that one became more negative and they're balanced. All right, let's see how it did. Cool. I like that. All right, thanks, man. Well, I'll see you later. All right, I hope we have some ice tables on this next one. 'Cause that's what our homework's been going over, but our Methodist stuff's been going over. I didn't score on that one. Okay. Write a balanced chemical equation for the reaction of weak acid, HCN. So how would you say that, HCN? Hydrocarbon nitrate. Or nitrogen, it's hard.
It's cyanide.
Oh, okay.
I don't know. It has a common name, I can't remember. Hydrogen cyanide, no. Something.
16A, how many problems are there? Oh, wow, 32. Okay. So that's H, C, and with water. So HCN, that's aqueous, right?
Mm-hmm.
plus H2O liquid. Correct, this is all getting set up?
Yep.
So wouldn't this go to H sub 2 CN positive? And this would be OH negative?
No, because it's saying that this is a weak acid, so what will happen to
Oh.
this?
Oh, this is, oh, okay, I know this one, This is what makes hydronium, correct?
Yeah.
And that means if that guy's lost, this is just carbon, nitrogen?
Yeah, and that's cyanide.
That's still cyanide?
Yeah, and so I don't know, I think, I'll look it up, but I think it's like hydrogen.
That's right.
HCN.
Okay, HCN. Aqueous.
Yeah, hydrogen cyanide.
Hydrogen cyanide, okay.
And CN
Plus
minus is cyanide.
H sub 2 O liquid. And that goes to hydronium. You ever had hydronium? Really, it tastes really good. I had no idea actually. Isn't that just acidic water?
Yeah, I don't know.
Is that considered a liquid or an aqueous? An aqueous.
Aqueous.
And CN negative, and that would be, I'm guessing, an aqueous.
Yeah.
Okay, because I remember the one that really stays liquid is the H2O, or that's one. Okay.
And
Do not subscript the phase symbols. Oh, okay.
Do not subscript.
So I think they want me to put like subscript aqueous.
Oh, weird. That needs to be an arrow, not a plus, between H2 and H.
Good point. Does it need to be back and forth arrow or to our right arrow?
I think you're fine.
Okay.
I'm not sure.
I'm gonna do the back and forth arrow.
I can see for.
I think so, because I had that question on one of these other ones. Okay. Complete the Ka expression for this reaction. Okay, I'm glad we're going on. This is exactly what our notes have been on. So the Ka, what's Ka? That, okay, so I know like K, isn't K usually like rate?
Yeah.
So is K is like,
Yeah, it's an equilibrium rate.
oh no, K is equilibrium, little k is rate. Capital K is equilibrium.
Equilibrium.
So is this-
Still has to do with rate, but.
Is this
equilibrium-
acid? Is the little sub?
Yeah.
So K will go, I don't know if it's equilibrium or rate, but something like that. And then the A is acid.
Yeah. Because you also have a KB.
So is this a certain type of, this is a certain type of formula, correct?
Mm-hmm. Let's see if I can find it.
Should be,
Acid base equilibrium. Chapter 16.
Hi. Okay, at 11:30? Okay, perfect. Are you going 264? Yeah. 265.
Anyway, yeah, Ka, what you're gonna, here we go. What's your little Ka?
That's it, right?
Acid ionization.
oh, that's the same
constant.
thing as before. Oh, that's the same thing as equilibrium, products over reactants.
Yep.
Duh. It's just now saying that the A's are, this is what it is with the acid.
Yep.
So, and see how he says always, always, always write out your stuff. Okay, now that's what we have right there. Oh, duh. That's all it wanted me to do.
Good, how are you?
And I did that. Cool. Okay. HCN aqueous H2O sub liquid. Okay, got the plus, got the negative aqueous. Got the H3O on top. Nice. I like that. Green. Cool. Okay, consider 3 generic acids. Oh, this is easy. I know this one. So, the strongest acids dissociate.
Yep.
So that means that X, dude, is the strongest acid, the one that's associated. Would you say associated?
Yeah, you could say associated.
That guy's somewhat, and that one's not really at all,
Yeah.
which is weak. Okay, check.